All right, we're going to go through the second page of our notes for 3.1. This time we're starting with the factored form. Go ahead and write these labels at the top since they're not there. Just to remind you, the factored form is in the middle column. Vertex form is on the right. And standard form is on the left. Okay, this time we're starting with the factored form, the one in the middle. And it's sometimes called intercept form because it's so easy to find the x-intercepts. So notice the x-intercepts are in this column. We're going to find our x-intercepts by replacing the y with 0. Okay, so we've replaced the y with 0. We have an equation that's easy to get solutions for. The only way a product can equal 0 is if one of the factors is 0. 2 is never 0. But if x minus 3 is 0, in other words, if x is 3, we'll have a 0, 2 times 0 times something else. That product's going to be 0. If x is negative 1, we'll have 2 times negative 4 times 0, which is 0. 0 times anything is 0. So for our x-intercepts, we have 3, 0, and negative 1, 0. So that intercept form or that factored form, it's easy to find the x-intercepts. Okay, from there, we're going to find the standard form. We're going to multiply this out and put it in standard form. So I'm going to use the box method of multiplication. We're just going to multiply the x minus 3 and the x plus 1, and then we'll distribute the 2. So x times x is x squared. X times negative 3 is negative 3x. X times 1 is 1x. And 1 times negative 3 is negative 3. So if we add those guys up, x squared plus negative 3x plus x minus 3, we have y equals 2 x squared minus 2x minus 3. And we don't have to use the box method. You could distribute, but be careful doing it. The 2, I'm going to distribute it last. So then we have y equals 2x squared minus 4x. Let's write it down here where I have more room. Minus 6. There's our standard form. Okay? There's our standard form. We can easily find the y-intercept by plugging in x equals 0. If we plug in 0, we get y equals 2 times 0 squared is still 0. 4 times 0 is 0. Do you notice that in the standard form, the y-intercept happens at c. It's 0, c. So in this case, the negative 6 is our y-intercept. So the point 0, negative 6 is where we'll cross the y-axis. And because a is 2, it's a positive number, it's going to open up. Positive, it opens up. Negative, it opens down. This is a positive. Okay, so it's going to open up. All right, last thing we have to do is find that vertex form. So we're going to go from the standard form to the vertex form. So take my standard form. I'm going to group the x terms together. I have to have a coefficient of 1 in front of the x squared to make a perfect square. So this is the process of completing the square is what we need to use. So we factor out a 2. Because we have to have a coefficient of 1 in front of the x squared to complete the square. Now what we're going to do is we're going to add something to make this a perfect square trinomial inside the parentheses. And whatever I add, I have to subtract that back off. But notice inside the parentheses, I'm adding something, but overall, I'm going to add 2 times something. So I have to adjust a little bit, adjust my process. So what do we add to complete the square? We take the coefficient of x and we chop it in half and we square it. That's -1 squared, which is 1. So we're going to add 1 to make what's inside these parentheses a perfect square trinomial. It looks like we just added 1, but we really added 2 because 2 times 1 is 2. See that right there? 2 times 1 is 2. So to adjust for that, we're going to subtract the 2 back away. We're now going to write our trinomial as a binomial squared. Remember, it's always x and then b over 2. So our b over 2 was -1. And there is our vertex form. Now I want you to notice that that's a x minus h squared plus our k. So h is 1 and k is -8. We already knew that a was 2. Our vertex is 1 comma -8. That would be the turning point. Axis of symmetry would be the vertical line through the vertex. It's always x equals h. So in this case, x symmetry is the line x equals 1. All right, let's do the last one to finish out our notes. So this time we are given the vertex form, and we're going to come up with all the information. Notice a is -1, so it's going to open down. H is 1. Let me write that form down. It's -1, x minus 1 squared plus 9. There's our a. Line them up. There's my x minus h squared plus my k. So h is 1, k is 9. If you look at it, the h value is always going to be what's inside the parentheses, what's making the inside of the parentheses equal to 0. So our vertex is 1 comma 9. And the axis of symmetry is going to be x equals 1. It's that line. All right, so we're going to go to the standard form next. And what I need you to remember is that x minus 1 squared is x minus 1 times x minus 1. So we'll multiply x minus 1 times x minus 1 and get x squared, x times -1, x times -1, -1 times -1. We're going to have a little dot there, it's bugging me. Okay, so x squared minus x plus 1. So what we have is y equals negative of x squared minus 2x plus 1, but we still have a plus 9 back here. I should have written it all down here. So what do we have? Let's distribute the negative. We've got negative x squared plus 2x minus 1 plus 9. So our standard form is going to be y equals negative x squared plus 2x plus 8. There's our standard form. Now, our a is -1, so it opens down. Negative value of a, it opens down. We can also see that from the vertex form. To find the y-intercept, replace the x equals 0 with 0. Notice what you're going to get. You're going to get 8. So our y-intercept is going to be 0, 8. Okay. Last thing we're going to fill in. Let's find the factored form. So I'm going to start working with my vertex form. Not with a vertex form, I'm going to start working with the standard form. I'm going to start from the standard form, and I'm going to go to the factored form. So we're going to factor out a negative. And then we're going to look at A times C for what's inside the parentheses, not just work with what's inside the parentheses. A is 1, C is -8, so A times C is -8. We're going to find two numbers that have a product of -8 and a sum of -2. It's going to be -4 and +2. I'm going to go ahead and do the box. X squared. Middle term we're going to split as -4x and 2x. GCF for the top row, for the bottom row, for the first column, for the second column. That means my factored form is going to be, don't forget the negative of x minus 4 times x plus 2. Okay, there's our factored form. I want to find the x-intercepts. We just find out when y is 0. Oops, that wasn't a +4, it's a -4. So we look at when x minus 4 is 0. It's going to happen when x is 4. We look at when x plus 2 is 0. It's going to happen when x is -2. So our x-intercepts are going to be 4, 0 and -2, 0. And we're going to do one more example because this is what we're doing in class as well. We're going to look at example 4 on the homework. So I'm going to flip over to problem number 4 in the homework. And to find the y-intercept, we're going to replace the x with 0. If I replace the x with 0, we get -16. Because a is -2, there's our a, our b, and our c. A is -2, so it's going to open down. Then I'm going to find my factored form from there. So I'm going to start with my y, or f of x. Remember, f of x is just a fancy way of writing y. I'll come back to f of x at the end. How do we get the factored form? Well, the first thing we have to do is factor out the -2. Notice this one's going down rather than across. In the notes we went across. In this one we're going down. So everything for problem number 4 goes down. Okay? Starting with the standard form, get all the other information in that column. So we're going to factor out a -2. Then I need a times c. I need two numbers that multiply to create 8 but have a sum of -6. That's going to be -2 and -4. The student who's been paying attention knows you can get the factored form from here without doing the table, but if you need the table, we do the table. GCF for the first row, second row, first column, second column. We'll have our factored form. And double check your answers. X times x is x squared. X times -2 is -2x. X times -4 is -4x, and -2 times -4 is +8. That's x squared minus 6x plus 8. And if we distribute the negative 2, it comes back to negative 2x squared plus 12x minus 16, which is what we started with. So we have negative 2, and then we have x minus 2, x minus 4, and that's our factored form. From that factored form, we can get our x-intercepts. They're going to be 2, 0, and 4, 0. Notice it's opposite, because when x minus 2 equals 0, you add 2 to both sides, you have x equals positive 2. Okay? And we're going to do the vertex form. So starting from our standard form. What's my standard form again? Y equals negative 2x squared plus 12x minus 16. So to get the vertex form, we're going to group just the x terms together, leaving the minus 16 out back. We're going to divide out the negative 2. And then we're going to add whatever it takes to make this a perfect square. So what's it going to be? Take the coefficient of x and chop it in half. So negative 6 chopped in half is negative 3. Square it, we get 9. So we're going to add 9. Looks like we added 9, but we really subtracted 18 because negative 2 times 9 is negative 18. So out back here, we're going to have to add 18. Should have written a little smaller, yes. Let me scrunch it up a little bit. We'll write a little smaller. Negative 2 x squared minus 6x minus 16. So we add a 9. Looks like we added a 9, but we really subtracted an 18. So we'll add an 18 to balance the equation. Okay. So then we finish it off by doing... I'll go back to f of x because that was our original notation. So f of x equals negative 2. And I want you to get comfortable with the idea that f of x and y are the same thing. Take your trinomial, write it as a binomial squared. Remember how it's x and then the b over 2, which our b over 2 is negative 3. Negative 16 plus 18 is 2. So there's our vertex form. Okay. The vertex, that's a x minus h, so h is 3, plus k, k is 2. So our vertex is 3, 2. We knew that it opened down. Our axis of symmetry is the line x equals 3, and we are finished with problem number 4.